In this video, we're going to revisit the list data structure to give example uses of many of its methods. In the introduction, we saw several examples of how we can use lists to store other objects of various types in an ordered collection. Lists are defined using square brackets and can be explicitly given elements by providing a list of comma-separated values. Lists are immutable, and we've already seen how we can add and remove elements from a list. We can index and slice lists to get access to the individual elements or ranges of elements within the list. And we even saw in the introduction that lists contain not just data, but have functionality associated with them in the form of methods. Namely, the append and extend methods were demonstrated. There are actually many methods associated with the list. And then in the section here, I'm actually going to do a quick example of each of these. So let's first start with a list of fruits containing orange, apple, and pear. And now the append method adds an element to the end of the list. So we can add the string banana by passing it as an argument to the append method. Do notice that in order to append the string banana to our fruits list, we must use the name fruits followed by a dot, and then the method name, append, with its argument list. This is because the method append is operating on this specific list fruits. You'll see more of how this works when you get to the notebook on classes. Similarly, we can extend the list with several items using the extend method. The method can take any iterable object and will add those elements to the end of the list. So fruits.extend, and then we're going to pass here a list of strings. And we'll see in the output that they were indeed appended to the end of the list one after another. And moreover, they were appended in the order that we specified with the list passed to extend. The insert method can be used to add a new element at a specific location, shifting all other elements down by one to make room for the new element. So if I type fruits.insert and I pass the index 3 and then the string grape, this will actually insert the string grape at position 3. And if you look at the output, you'll see that the string grape does appear at index 3 and that all other strings were shifted over to the right to make room for this new element. The remove method will remove the first instance of the specified element from the list. So if I attempt to remove apple, we'll see that the element at index 1 was removed, but the second instance of apple here was not removed. The pop method is similar to remove, but it removes the element specified by index rather than by value. And if no index is given, then it removes the value located at the end of the list. Also, after removing an element, the pop method will return that element. And so we see here in the output that banana was returned by the pop method. And if we output the entire list again, we see that banana no longer appears at the end of the list. The clear method removes all elements from the list. However, do note that it does not remove the list itself. As you see in the output here, we still have an empty list after this method returns. Now, before the next function, let's actually recreate our list so we have something to work with. And then we're going to try the index method. So this method returns the numeric index of the first instance of the passed element. So this is going to search our fruits list until it finds an element that equals the argument passed here and returns the index of where it was found. So if the element could not be found, then the method raises a value error exception. Also, there are two optional arguments that we can pass to this method, one being the start index and the other the end index. These values are interpreted as a slice and restrict the search for the passed element to the range specified by that slice. So if I pass index 4 as the start value, then you see that this method returns index 6, which is the second instance of banana in the list. The count method returns the number of elements that match a given argument. So if we were to ask for the count of the string apple in our list, we get back 2, since there are indeed 2 instances of apple. However, if we were to ask for the count of tangerine, we would get back 0, since that string does not appear in our list. The sort method will actually sort all the elements in our list. This method takes 2 optional arguments. The first is a key function, which you specify, and this function should take a single parameter, which will be an element from the list, and should return a comparison key that is to be used to compare the elements of the list during sorting. For our list of strings, a comparison key could be the lowercase version of each string, so that we compare strings equally. That is, we don't have an issue where lowercase is considered less than an uppercase, for instance. The comparison key could even be a hash value depending on what your need is. And the second argument is a Boolean that, if set to true, will actually return the list sorted from large to small. And if it's false, which is the default, it will return the list from small to large. So you see here in our output, we have all the strings sorted lexicographically from small to large. And I've given you a link here to the sorted function, which actually has some more explanation on the arguments for this, as well as some of the options given here. The sorted function and the sort method are very similar, and you'll find often that the documentation of one will point to the other. But in any case, I've given you the link here for you to check out. The reverse method, no surprise, reverses the elements in the list. So if I type fruits.reverse and then output fruits, you'll see that we get the exact opposite ordering as we had in the previous output. And the last method I want to talk about is the copy method, which actually returns a shallow copy of the list. That is, the list object itself is copied, but its elements still refer to the same objects. So for a detailed look at assignments and copies, both shallow and deep copies, take a look at the assignments and copies notebook from the names chapter. So for example here, we can use the copy method to copy the fruits list and bind that to the name fruits copy. And then we can use the reverse method to reverse fruits copy. And when we print out both the original fruits list and the fruits copy, this has the expected result that one list is in the opposite order from the other. If we repeat this, but we omit the copy method, you're going to see that even though we reverse fruits copy, both lists appear in the same order in the output now. And this is because the assignment operator in Python does not perform copies. Instead, it simply binds the name on the left to the object on the right. So both names fruits and fruits copy point to or refer to the same list in this second example. Now, before we wrap up this video, I'd like to introduce the Dell function. This function is not specific to lists, but can be used similarly to the pop method, except that Dell does not return the value after removal. For example, if we had a list of numbers, and then we wrote del a at 0, and then output a, you see that the first element of our list was removed. The -1 here is no longer present in the output. In addition to passing a single element with using del, we could remove an entire slice as follows. And so in this slice, we're removing the elements 2 and 3. But that slice could specify every element in the list, which would result in an empty list like we see here. Now, one major difference between del and pop is that we can also use del to remove names, not just the elements of lists like we've been doing here. So if I write del a and then try to print out a, you see that I get a name error stating that a is not defined. So the del statement actually removed the name a from the local namespace. So when we attempted to use it in the next line, the interpreter was unable to find it and raised an exception stating that.